This video is the last video for section 3.1, and in it we're going to cover example 3 here. We need to take a look at one more type of situation you can get into when you're doing an integration by parts problem. So notice again in this example we have two separate functions. We have e to the x and we have sine x. Neither one are related. The e to the x, of course, is an exponential function. Sine of x is a trig function. And if we go back and look at our mnemonics, we can see that exponential and trig are both at the bottom of the list, and it doesn't really matter which one you pick. I'm going to go ahead and let u be sine x. I'm going to let u be sine x. So if u is equal to sine x, then that means dv is going to be e to the x dx. And then, of course, we integrate and take the derivative to find du and v. So what would du be? And what would v be? Go ahead and write those down real quick. Okay, you should have got that u is cosine of x dx, and you should have gotten that v is e to the x. Good. Okay, so let's go ahead and go through integration by parts here. So rewriting the integral, we have the integral of e to the x times sine x dx, and this is equal to u times v, or sine of x times e to the x, minus the integral of v du, so minus the integral of v, which is e to the x, times du, which is cosine of x dx. And you'll notice after we've done this first iteration through integration by parts, we get another integral that is no simpler than the one we started with. It still has an exponential and a trig function, and all the previous examples we looked at, our integrals got simpler. This one, that is not the case. But let's go ahead and go through this one more time. So we're going to take this integral and do it one more time. So again, I'm going to let u be my trig function. So u in this case is going to be cosine x, and then dv is going to be my leftover stuff, e to the x dx. That means du is going to be negative sine x dx, and it means that v is going to be e to the x. And so we can go ahead and rewrite this. Then we get that we have e to the x sine x minus, and then this is our second integration by parts iteration. So again, we have u times v. U times v is going to be e to the x cosine x minus the integral of v du. So minus e to the x times negative sine x dx. All right. So before we go any further, I just want to clean this up a little bit. Let's go ahead and distribute our negative sign in. So this negative sign needs to go to both terms inside the brackets there. When we do that, we get that this is equal to e to the x sine x minus e to the x cosine x. And then distributing the negative here, we have negative and negative, so we have plus the integral of e to the x. Oh, and I actually forgot about the negative sign inside. So there's actually 3 negative signs. So this should not be a positive. This should be a negative, correct? So we have negative e to the x sine x dx. Now, I want you to notice that after going through this twice, we end up with an integral on the right-hand side that is precisely the integral that we started with. Remember, right here, this left-hand side is equal to the integral of e to the x sine x dx. And so it kind of looks like we're stuck. We're just going around in circles, but there is something that we can do, and because these two integrals are the same, we can actually just do algebra with them. We can go ahead and add this integral. We can add it to the other side. So when you, because it's a minus on this side, so when you move it to the other side, it's going to become a positive. So you end up with two of these integrals on that side. So you end up with 2 times the integral of e to the x sine x dx, and then on the right hand side all that's left is e to the x sine x minus e to the x cosine x. And of course our original problem was to figure out what that integral is, but now it's 2 times that. Well, it's just a little bit more algebra, right? How do we get rid of the 2? We just divide both sides by 2. Divide both sides by 2. Those 2's cancel. And we get our final answer. We get that the integral of e to the x sine x dx is that right-hand side over 2 minus e to the x cosine x over 2. And then, of course, we have, don't forget, we do have a constant of integration. We can't leave that off, but that is your answer. Hopefully that makes sense, and that'll do it for section 3.1. I will post the solution for example 4 in the lecture so you can see that one work through, but that's going to do it. Have a good day.